All right, well, let's continue our look at trigonometric functions. So last time we got them defined. We know that sine of t for any number t coming in is just the y-coordinate we get after we move t on the unit circle. And cosine is the x-coordinate. And then from there we had the ratios and the reciprocals, and that got us the other functions. Now what I want us to start doing now is start identifying some general properties of those functions. Start to nail down some of their behaviors. Because if I haven't said it yet, I will say it. The mantra I have, functions model behaviors. That's why so many non-math majors take courses such as this one. It's to be comfortable with functions so you can use them to model something more relevant to your field. That's the long and short of it. That's why a lot of you are in this course. It's to be more familiar with functions. So let's look at it backwards. You need to know how a function behaves so that you can use that function to model behavior. Because you can't model behavior with something you don't know how it behaves. That doesn't make any sense. So we have to know how these things are acting so we can use them in the way we need to. So we're going to start finding some properties. We're going to start with this video asking ourselves, when is our big six functions undefined, if they are ever undefined? When are they zero? When are they positive? When are they negative? Just some basic questions here. So let's see what we got. So first of all, where are they undefined? Or equivalently, where is or what is the domain of each function? And to answer that, first let me remind you, in this class, we are dealing exclusively with real valued functions. So I need all the real numbers in that also produce real numbers out. So in this example I have here, h of x being the square root of 1 minus x equal 5 would not be in the domain. Because if you were to put 5 into this function equation, you would have the square root of 1 minus 5, the square root of negative 4, which is now 2i. Which is fine, that is a number, it's just an imaginary number, it's a complex number. And since we're dealing with real valued functions, I need all the real numbers in to get real numbers out, so 5 is not in the domain of real valued function h of x. In fact, anything greater than 1 is going to produce square root of negative number. So anything greater than 1 must be excluded from my domain. And everything left is going to be in my domain. So you could say either x less than or equal to 1 is your domain, or equivalently negative infinity to 1 with a square bracket. If you're familiar with that or not, that's fine. I'm not really going to get into interval notation in this class. That's not really something we worry about in this class. But if you choose to use it, then by all means use it. Whichever works for you. So that's what it means to have a domain for a real valued function. Now sine and cosine, we'll start with that. We'll start simple. I believe that both of those have to have domains being all real numbers. Let me pull this up here. Right, let me rewrite. Just look at these again. You've seen them before. Sine of t is y and cosine of t is x. Meaning, if I go some number around the unit circle, wherever I stop, sine is the y-coordinate, cosine is the x-coordinate. Now, any real number t I choose to go around the unit circle, wherever I stop, I'm going to have some terminal point, and it's going to have some x and y coordinate both being real numbers. So if you were to gaze at my beautifully drawn unit circle here, you'll see that no matter where you end up, wherever you end up, you have some x comma y point, and the x coordinate's got to be between negative 1 and 1. The y coordinate's got to be between negative 1 and 1. It's always going to be defined. It's always going to be a real number. So the domains of cosine and sine are all real numbers. Right? All real numbers. And also, because they bounce between negative 1 and 1, like I said, their ranges are going to be negative 1 to 1, which we write that way. Or you could say negative 1 less than or equal to x, which is less than or equal to 1, however you choose to do it. But that's going to be nice. That's going to be niceness. That's going to be true only for sine and cosine. There are restrictions on all of our remaining functions. And as I mentioned before, I believe, that's true because tangent's undefined whenever x is 0. And same for secant. Cotangent's undefined whenever y is 0. Same for cosecant. And this point right here, 1, 0, y is 0 there. So cosecant of 0 and cotangent of 0 are both undefined. Similarly, if I go up to here, if I go pi over 2 for t, my x-coordinate is now 0. So tangent's undefined, secant's undefined. We have restrictions on our domains for all of the remaining functions. So let's kind of hammer that out, be a little more formal, show you a lot of words. It's still not that much information. As I had said, tangent and secant are undefined whenever cosine is 0, which is here and here. So pi over 2, 3 pi over 2. And you can keep going, right? 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. And you can also go in the negative direction. So negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, etc., etc. So the only real simple way, the best way to say what our domain is that. It's all of the things looking like pi over 2 plus some integer multiple of pi. That's where it's undefined, so that's what we have to exclude. So the takeaway from this is also that these functions are undefined whenever you have some input looking like pi over 2 plus some multiple of pi. So 3 pi over 2, 5 pi over 2, 100 million pi over 2. Well, 100 million and 1 pi over 2, now that I think about it. Because 100 million pi over 2, that's a 500,000 pi. That's going to be cosine of 500,000 pi is 1. But pi over 2 plus k pi, simplify that, however you choose to simplify that. Secant and tangent are undefined there. Similarly, whenever sine is 0, you've got undefined cotangent and cosecants. And sine is 0 whenever you're looking at this point or this point, which happens 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and also 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So all of the integer multiples of pi, you have undefined cotangent, cosecant. So the domain is everything except for those integer multiples of pi. So everything except for k pi, where k is any integer. Just something to hold on to. We'll get into the ranges of these functions sometime. They're not really relevant, and you'll see why when we actually get to graphs of the other 4 functions. The real functions you need to remember the range for is sine and cosine, but that's fairly obvious, right? Negative 1 to 1. That's what they do. So I just have one last thing to kind of mention here, and then we will be done for a bit. And that is, we know when it's 0, right? I already mentioned that, right? Sine is 0 here and here. Cosine is 0 in these 2 points. So the same values that gave you undefined values for secant, cosecant, tangent, cotangent are also the zeros of sine and cosine. So sine and tangent are 0 whenever you got that pi over 2 plus k pi person. Cosine and cotangent are 0 whenever you got k pi person. And fun factoid, secant and cosecant are never ever 0. And you can stop and think about that for a moment and think, okay, so I've got secant being 1 over sine. So I've got 1 over some number between negative 1 and 1. When is that 0? And the answer is never. So secant and cosecant can never be 0. And so all that's left is remembering when is sine positive, when is cosine positive, when is tangent positive. And some of you might know this memory vice. All students take calculus, or everything's positive here, sine's positive here, tangent's positive here, cosine's positive here. But no, there's enough things in life to memorize. That does not need to be one. Just look at this. First quadrant. X is positive, Y is positive. So cosine is positive, sine is positive. That ratio is also positive. Second quadrant. X is now negative. So cosine is negative. Y is still positive, sine is still positive. Now the ratio of y to x is now positive over negative, so that's negative. So tangent becomes negative as well. Third quadrant, both x and y are negative. So sine's negative, cosine's negative, and tangent being the ratio of now two negative numbers becomes positive. And lastly, fourth quadrant, x becomes positive, y is still negative, so we got positive cosine, negative tangent. Not really worth memorizing. Better if you just understood that. Not really going to do more than that. And you may be wondering, Mr. Terrell, why do we bother with all this? Why do we bother knowing when something's positive, negative, or zero, or undefined? To which I have this to tell you. If you want to know how a function's behaving, you should know at least that much. And besides, it can go a pretty long way in checking yourself, in making sure what you see is what you should see. So I have a hypothetical, which is not actually that hypothetical. This does happen. Happens all the time. You got to compute the cosine of 9 pi over 2. And someone in your group tells you, oh, it's 0.9697. Straight-faced, no hesitation. And you look at them funny, and they say, no, really? And they hold up the calculator where they had crunched the number, and there it is, 0.9697. Is that right? The calculator said so, so it's got to be right. Except, no. This is not true. Cosine of 9 pi over 2 is not 0.9697. So here's my question. What is it really? What is it really? And maybe also what went wrong? What led your colleague to be so confidently wrong? So tell me, and we'll see what we got. And what we got, hopefully we agree pretty quickly that, okay, cosine of 9 pi over 2, t is 9 pi over 2, that's going to be blah, 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 duh. Doesn't really matter, though, because cosine is 0 at pi over 2 plus k pi, right? So even if we ended up down here, cosine would still be 0. Cosine of 9 pi over 2 should be 0. The issue that happened is going to be a common issue with a lot of students. Someone ran it through their calculator in degree mode. So the calculator interpreted this as the cosine of 9 pi over 2 degrees, which is very, very wrong. We need 9 pi over 2 radians. The only time you should ever work in degrees is when you're given something in degrees. Otherwise, it's radians, plain and simple. And that's really all we got to say on that. We got some general idea of behavior when something's 0, positive, negative, undefined. And we got, hopefully, at least a plea as to why we want to be able to say those things. So in the next video, we'll say just a little bit more, get a few more properties under our belts, and that should be it. So have a good one.